Good night, everyone. Soil mechanics and consolidation settlement in soil. So we have a structure like this, and which is located on the top of a soil layer. We want to calculate the consolidation settlement of this structure. So our building is constructed over three soil layers, and we want to calculate the long-term consolidation settlement of the clay layer. So these three layers of silt, sand, and clay are provided with their information like height and a unit weight, and the extra weight of a structure additional pressure to the soil is 1200 pound per square feet. Clay soil is fully saturated and soil is normal consolidated. We want to calculate the settlement at the midsection of our clay soil. So if you want to do that, we need to calculate the effective stress first at the halfway through of our clay layer, which is like if we start from the top, we have 10 feet of silt by 10 times 80. We have 15 feet of sand by unit weight of 120, 15 times 120. And then when we enter to the clay soil, because the water surface located here, we need to calculate the we have to effective unit weight, which is saturated minus we have to subtract the unit weight of water from the gamma provided, which is 105. That's why we have 105 minus 62.4, which is unit weight of water in USCS times halfway through the layer. If you do so, it just gives you effective stress at A is a 3026 pound per feet squared, and the delta sigma is 1200 provided with the problem statement. Then if you remember, we have three categories of consolidation. Either our case one, our soil is over consolidated, or normal consolidated, or 1 feet is located in over consolidated and the other foot is on a normal consolidation. In our case, problem statement clearly said our soil is normal consolidated. So in that case, we definitely know our case is case 2. That's a normal consolidation. We are in this part of the consolidation diagram and we need to use this formula. So first of all, we need to calculate compression coefficient C sub C, and that's come from the equation based of liquid limit. And if you replace that from the liquid limit provided of problem statement, you can get compression coefficient of 0.36. And the other part, the problem is said clay is fully saturated by the problem statement. So we can use SR times E is omega times GS. Definitely SR is 1 because it's fully saturated, and you can easily get the void ratio of the soil and use it and plug it in this equation to get everything done. So settlement consolidation comes from this equation, and if you replace all the information in the equation, you can easily get like settlement consolidation is 0.5119 feet. Don't forget to convert your calculation based off the height of the layer, then it just gives us a feet, whatever in feet, multiplied by 12 inch per feet, reported by 6.14 inches. So one can say the settlement consolidation at the center of our clay soil is equal to 6.14 inches. Thank you. We'll solve more problems.